to look at trigonometry. And remember last time we looked at a question which involved the diagram, and there was a condition and there was a domain. But now we are now looking at the second type of question which you can come across in trigonometry, and this one is infamous, especially in grade 12. They like this question, they bring it a lot because it has got a lot of applications and you can almost do so many tricks with it. So in this question they will give you if sine 2 is equal to v. Now the minute they give you if sine of a number is equal to v, obviously there will be some follow-on question. Maybe the first follow-on question will be find tan 2. Now what I would like to do is I would like to first of all use the information that I'm given. So I'm just going to ignore that part a bit and say, look, I'm not going to look at the question yet. I'm just going to concentrate on working with what they have given me. Now, from what they have given me, I know that sine 2 is equal to v. So sine 2 is equal to v. Now, this can compel me, or it can give me the right to say, what? Remember, there is an identity which says sine squared 2 plus cos squared 2 is equal to 1. That identity, we know it. So which would then mean that sine squared 2 plus cos squared 2 is equal to 1, which means if I want cos squared 2, it's equal to 1 minus sine squared 2. Do you see that? That is a very simple case where I now can find cos. So if I want cos, I know cos of 2 is equal to square root of 1 minus sine squared 2. And forgive me for squeezing it there, but I wanted to make sure that some of you can understand that here I'm strictly using the identity. And I'm lucky because they asked this particular question, this question 2, using sign, so I can easily just use the identity. So now if I am using the identity, I can now then say, but remember, sine squared 2 in this case is actually v squared. So cos 2, according to that one, is going to be square root of 1 minus v squared. Now once I can do that, I now know that every time I'm given sine, I can always find cos. Let's have another example. For instance, if they say cos 2 cos 6 is equal to t. Let's say cos t, I can immediately say, oh wait, I've been given cos 6. I can find sine 6 is equal to square root of 1 minus t squared. How did I find that sine 6? Sine 6, because I know that sine 6 squared plus cos 6 squared is equal to 1. So, and I know that cos 6 squared is actually t squared plus sine squared 6 is equal to 1. So sine squared 6 is equal to 1 minus t squared. And then sine 6 is just going to be square root of 1 minus t squared. Do you see that? I can have another one. I'm just winding up time here. So if sine is equal to 4, I know sine 4 is equal to m. Then I know immediately that I can find my cos. Cos 4 will be equal to square root of 1 minus m squared. So for sine and cos, and I need to write the reasons so the examiner can understand what I'm telling you. What I'm saying, cos squared 4 plus sine squared 4 is equal to 1, and then you can play around with that to show the examiner you know what you are doing. Now this question is normally it normally has a lot of other follow-on questions, but well, let's look at those follow-on questions, and maybe you can understand where we are coming from. So if they say cos 8 is equal to p, if cos 8 is equal to p, find tan 8. That's nice. Tan is fairly simple. That's number 1. Find b, find cos 16. Interesting. Where did the 16 come from? And then c, I'm just going to do 3 here. Cos say 82. Wow. So these are all numbers. Now when we look at this question, remember what I said, the first thing that should come into your mind is, oh, I've got cos 8, I can find sine 8. And then if you can find sine 8, you say this is square root of 1 minus p squared, and you can always explain it by saying sine squared 8 plus cos squared 8 is equal to 1, and you can continue to just show the examiner you know what you are doing. Now once you have done that, you now say, okay, but wait, let's look at their a. Their a just wants tan 8, so we know that tan 8 is equal to sine 8 over cos 8, which is then in turn going to be equal to, if I continue there, I don't want to put equal signs in the same line, so I'm just going to say there, okay, that happens die hard. So sine 8, I know it's square root of 1 minus p squared, but cos 8 is just p, and then I'm done. That I now have expressed tan 8 in terms of p. Now let's go to the next one very quickly. They want cos 16. Cos 16. Now, how do I get cos 16 from 8? Now it must be, it can only be, because I already know we have done identities. So this is cos 8 plus 8. Do you see that? Yes, which means that I can simply expand that one, saying cos 8 minus, because there's a plus there, it's for cos. If you check your identities, sine 8 sine 8, which is actually like that. Now once I've seen that, I now know, I remember cos 8 on the other side is equal to p, and remember our sine 8 is equal to square root of 1 minus p squared. Do you see that? So I can substitute that. This is p multiplied by p minus square root of 1 minus p squared multiplied by another sign, which is square root of 1 minus p squared. And I'm deliberately making sure that I'm expanding it. I'm using the expansion, I'm using the grade 12 identities, so that now I can then say this is going to be p squared minus this one times this one is going to give us 1 minus p squared. Do you see that? If I multiply those two brackets, which means that we are going to have 2p squared minus 1. And I've now found that one. Now let's look at the last one. The last one, again, here now they are saying, just check what it was, by the way. It was cos 82. Cos 82, somehow I need to bring my 8 there. So I know that if I say 82 plus 8, I'll get 90. So 90 can be used. So I'm going to say this is cos 90 minus 8. Now there, remember I said we're going to talk about it, or you already looked at reduction. If you are not sure about reduction, you can go to the chapter of reduction, because this video you might watch it before you've done reduction. So you need to go and watch something called reduction 1 or reduction 2. So there you go. You're going to have, there is cos and there is 90 there. This is going to be sine. Cos 90 minus 8. If we are using the quadrant, 90 minus 8 goes somewhere here, right? Which means that cos here it's positive, which means that here it will be a positive. Then this will be sine 8. So remember to always check the sign, but we'll get into detail with that. Now sine 8, remember what we said, it is square root of 1 minus p squared. And then you are done. So that is basically how you would apply that to sine and cos. When it comes to tan, however, if someone gave you tan 3 is equal to k. Now, if someone gave you tan 3 is equal to k, now it's not gonna be easy for you to find sine and cos there. You can't use an identity, so you must draw a diagram. So sine 3 is equal to k over 1. So I'm just going to immediately go to k. Maybe I need to write it down somewhere. Tan 3 is equal to k over 1. Which means that I have now introduced a denominator. Now, remember tan is opposite over adjacent. Remember that tan is equal to opposite over adjacent. And here I just draw any simple triangle. I'm not in a rush. And then this is opposite is going to be k. And this is going to be 1. And if I use Pythagoras theorem, hypotenuse squared is equal to opposite squared plus adjacent squared, which is going to be r squared is equal to y squared plus x squared, which is going to give us opposite, which is k squared plus 1 squared. Do you see that? The opposite there. There you go. We've got our adjacent there. Adjacent, sorry. And our opposite there. We want our r. So our r is actually going to be equal to square root of k squared plus 1. Do you see that? Which is quite nice. And sometimes and this one, your r will always be equal to that. If they give you a domain, you can also use the domain. But usually it is not that complicated because you already put your 1 there. So it's going to be fine. So now I can now find my sine. Sine is opposite. Sine 3 is equal to, opposite is going to be k over hypotenuse, k squared plus 1. I can even find my cos. Cos 3 is going to be 1 over square root of k squared plus 1. And that, ladies and gentlemen, is the question of the diagram is the second question of trigonometry. Whenever you're looking at trigonometry, remember there's question 1, question 2. There are 7 in total, and we're going to go through all of those by the time you are through with this trigonometrical chapter.